So now that we know all the core rules for taking derivatives, what we want to look at next is cases where we can't necessarily take the derivative as normal. And so one case is when we can't always have y in terms of x, right? For example, if I have the equation y plus cosine y equals x cubed, this is definitely a graph, and it's not a function necessarily, but you can use Desmos as an example to like sketch out what this kind of function would be. You can't solve for y, but you can see what kind of equation you're going to get here. Equals x cubed. If we got, see, it's going to have this weird graph, and it might be obviously impossible analytically for you to be able to solve for y, but I might still want to know the slope of the tangent lines at different points. Like I might still want to know that, right? And so how can we go about doing that? And that's where implicit differentiation, we call this is not an explicit function of x. So y equals some function of x. That would be an explicit function of x. But an explicit function of y, explicit definition of y. But this is implicit because we're having a relationship between y and x, but we don't know what y is equal to in terms of x, right? And so while it's tricky to analyze, we may still want to find the derivative. So implicit differentiation is rather than solving for y, you can just take the derivative both sides of the equation, right? That's a core thing that you learn about equivalence in algebra and such, is that if I take the derivative of one side, right, then if I do something to one side of an equation, I got to do the same thing to the other side of the equation. And taking the derivative is something you can do to both sides of an equation. The key thing you have to recognize is every time you take a derivative of y or a function of y, you have to multiply by dy dx due to chain rule. So if I have y squared and I want to take the derivative with respect to x, you have to recognize that you don't just write that as 2y, which would be power rule. You got to because y itself is inside of x squared. By chain rule, I got to multiply by the derivative of y. We don't have to do that with x because when we take the derivative with x, like the derivative of x is just 1, right? Like the inner function is x, that's already like matching this variable here. But when we're taking the derivative with respect to x and it's a different variable, we got to do that. Like for example, if I take the derivative of cosine of x squared, right? What do I have to do is I have to do 2 cosine x, right, by power rule, and then by chain rule, I'm going to multiply my negative sine x. If you think of this guy as your y, then this guy is your dy dx, right? It's just a function of doing the chain rule there, right? So that's all it is. It's a fancy mask up representation of doing chain rule. You know, when I was learning calculus, I actually didn't know that. I just sort of followed the rule. I always put a dy dx, but at its core, it's because it's chain rule, right? And so let's take a look at like doing some examples. So here we're just going to take the derivative of both sides. And I prefer to use this notation when we're doing operations instead of the prime notation. I just think like it's a little clearer to me. So you'll see me using this notation for derivatives instead. It's the same thing, right? So derivative of x to the fourth is 4x cubed. Derivative of y squared is 2y. Then by chain rule, dy dx. Plus the derivative of y is not just 1, it's dy dx, right? Because it's not, this letter here doesn't match. And then the derivative of 7 is 0. Now, if you want to solve for the derivative, what you're going to do then is isolate. You're going to keep all the dy dx to one side, move everything without a dy dx to the other side here. And on these two, you're going to factor out a dy dx. So if I pull out a dy dx, I have 2y here. And pulling out of here, I just get 1. And then move anything without a dy dx to the other side, minus 4x cubed. And then you solve for dy dx like that. And you're getting minus 4x cubed over 2y plus 1. You just divide that out, and then that. Now, a couple things to note. You will get a function. You will get a derivative in terms of x and y. You can't just get it in terms of x. It's usually very difficult because it's nearly impossible to replace that y. But you at least get a derivative. So you do need an x and a y point to calculate the slope of a tangent line. I need an x and a y coordinate, one of the downsides of implicit differentiation. But still, we can still compute a derivative. All right, let's take a look at this one. Let's do d dx here. We're taking derivative of both sides, left and right side. So Derivative of this. Here we have two functions we're multiplying. One's y, the other's cosine x. I'm multiplying them together, so I have to do product rule. Derivative of the first one is dy dx times cosine x plus y times the derivative of cosine, which is negative sine x. Okay, so that completes that one. Sine y, it's chain rule. Derivative of sine is cosine y. Leave the inside alone. But then multiply by the derivative of the inside y, which is dy dx. Then we do derivative of x, which is 1. Derivative of y, which is dy dx. Now we want all the dy dx's over, so we're going to move this guy over to this side by subtracting dy dx, right? That will get rid of that. And then we also want to, anything without a dy dx, we want to move over, so we're going to add over here y sine x to get rid of that guy, right? Now everything with dy dx is over here, so we're going to factor out a dy dx. So this would be negative 1. This is a cosine x, and this is a cosine y, right? Equals 1 plus y sine x. And then last step, we just divide that over. So that's the process, right? Right, we take the derivative of both sides, right? We move all the terms with dy dx to one side, everything without a dy dx to the other side, and then you factor out the dy dx and move it over. All right, let's do this one here. Let's take the derivative of both sides here. This one is a product rule because I'm multiplying two functions. I'm multiplying x squared times tangent of y. So derivative of x squared is 2x. Leave the other one alone. That's product rule. And then x squared, derivative of tangent is secant squared. But then by chain rule, I got to multiply by dy dx, the derivative of y, because y is inside the tangent, right? And then derivative of 50y is 50 dy dx. So I'll move this to the other side because we want to get all the dy dx on one side. So it's 50 dy dx minus x squared secant squared y dy dx. We can then factor out the dy dx. 50 minus x squared secant squared y, right? Just pull it out of each of these and then divide it over. Divide this term over to get then the dy dx term. Like that. Okay. Let's look at an example. Which one could be used to find the slope of the line tangent to the curve like this? So again, we're going to take the derivative, and this is a bit more complicated, but it's the same idea. We're going to take derivative of both sides here. So remember inverse sine, if you don't remember the derivative, this is one that's usually harder to remember. It's 1 over a square root of 1 minus x squared, right? So when we take the derivative of this, it's going to be 1 over the square root of 1 minus whatever the inside part is. 2x squared plus y squared squared. That handles the inverse sine. But then we have something on the inside. So we got to, by chain rule, we're going to multiply derivative of the inside. What's inside the sine inverse, right? The inner function. Derivative of 2x squared is 4x. Derivative of y squared is 2y dy dx. Right? Then we'll take the derivative of this side. Write this as 2x to the negative 1. So we'll do that as power rule. So it'll be negative 2x to the negative 2. Right? Subtract 1 on the exponent. And then derivative of y squared is 2y dy dx. Now this guy you could write as negative 2 over x squared, which is probably what they do. So let's take a look at which one has these correct things. So we do need a, so this one doesn't have didn't do the chain rule correctly. This one did not have a dy dx here. That's wrong. This one has the dy dx, so that part's good. Minus 2 over x squared, 2, and this one looks good. And this one, anything wrong with this one? Oh, this one didn't square that inside. It's missing the square exponent here. So that's why it's C. Okay, let's say this is more conceptual, right? Which one does not require the use of the chain rule to find dy dx? And this is where it's tricky because implicit differentiation is, if you don't understand it's not chain rule, it might be a little tricky. So this one has an inner function inside of an outer function. So this is chain rule. This one is implicit differentiation. Implicit is technically chain rule, so not this one. This one, look, this is just power rule, right? So this one doesn't require chain rule. This one is implicit as well. So that requires chain rule. Anytime I do implicit differentiation, I'm ultimately doing chain rule. Let's find the derivative at a specific point here. So let's say I want to know the value of it at a point. You're just going to plug in those x and y values after you do it. So we're going to take the derivative of both sides here. So ddx, of both sides here. And so e to the 2y, the outer function is exponential, so it's e to the 2y, then times the derivative of the inner function, which is 2 dy dx, right? Minus exponential still y squared minus y. Then the inner function is y squared minus y. The derivative of that is 2y dy dx minus dy dx. Okay? And then that's equal to, and then derivative of this side is going to be 4x cubed minus derivative of x squared is 2x. Okay, so all the way, both left and right sides takes the derivative. Now here's the trick. You could try to solve for dy dx, but honestly, it's faster if you plug in the point directly at this point and then solve for dy dx. It just will simplify your math. So every time you see a y, we're going to plug in 0, 0, 0. This is 0. And every time there's an x, we're going to plug in 1. So let's see what we get. This is going to be e to the 0, which is 1. So this is 2 dy dx. This is also e to the 0. So that's going to be 1 minus 1. And then this is 0, so that's going to 0 that out. And this is just going to be minus dy dx, like that. And then this is going to be 4 minus 2. 4 minus 2 is 2. See how much easier it is when we plug in the numbers and then solve for dy dx. Now you have 2 of these. This becomes plus. 2 plus 1 is 3 of them. So 3 dy dx equals 2. And then dy dx is equal to 2 over 3. Okay? One more thing I want to show you is how do you do the second derivative. So you might have to do the second derivative. Well, it's very similar. You find the first derivative first. Right? So the derivative of this, we do product rule, right? So the derivative, derivative of x is 1 times y plus x times the derivative of y, dy dx. Derivative of x squared is 2x. Derivative of cosine y is minus sine y. Then by chain rule, because I have an inner function, dy dx. Or basically, anytime I take a derivative with a y in it, I got to throw in a dy dx. Now we want to solve for dy dx now. So we're going to move this guy over, this one over here. So you have a dy dx, you'll have an x from this guy, and you'll have a sine y. And then we're going to move this to the other side. So that's going to be 2x minus y. And then now you've solved for the first derivative. So step 1, when you do the second derivative, first step is to find the first derivative, right? And then we're just going to take the derivative of this, okay, to find the second derivative. But now we got to do a little tricky. We got to do quotient rule because we're dividing two things. So we're going to do bottom. Still implicit, though, because we have y's in here. Bottom times derivative of the top, which would be 2 minus dy dx, right? Minus top times the derivative of the bottom. Derivative of x is 1. Derivative of sine is cosine y. But then by chain rule, got to put a dy dx divided by the bottom squared. Okay. Now, you have these dy dx's, which you can then take this and plug straight into here for all these dy dx's. Now, it's going to be very messy because I didn't pick a problem that was necessarily very easy to solve, but that will give you an expression for the second derivative, right? And so you can see how it gets very ugly here. 1 plus cosine y, and then just times this thing. I'm not going to simplify because there's no point in simplifying. This is just to illustrate what the process is for you when you are asked to find, oh, this is supposed to be squared, x plus sine y, when you are asked to find the second derivative, right? So we're just going to use, don't forget when you do the second derivative, still have some y's in there. Got to throw in by chain rule some dy dx's, but we know what dy dx is, so we can substitute those in, right? Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.